My name is Martin. I work for Neo4j in developer relations. I'm a technical curriculum developer at Neo4j. So I want to spend a little bit of time talking about Neo4j and GenAI. You can see from all of the words that we are very much touting the AI line, as most organizations are right now. But let's talk about why we think this is important. So I just want to start with a statement, which is, if you don't know, large language models are not perfect, right? I have definitely been in this situation where somebody whispers in my ear. I mean, the meme says ChatGPT, replace that with Claude, Gemini, your large language model of choice. Just use ChatGPT, dude. But what are you talking about, right? That's simply not true. That doesn't make any sense to me. Because context is key, right? If you don't give our generative AI models the information they need in order to be able to provide a response that is human-like, well-formed, they generally don't do a good job. Yeah. I am going to spend the next sort of 8 minutes trying to tell you a little bit about why I think graphs are a good way of doing that. We have some t-shirts to give out, and so I actually borrowed this off the t-shirts. Graphs plus agents is better together. That is our We Are Developers strapline. And really, if we look at that sort of like left brain, right brain dynamic, agents are incredibly good at language, reasoning, creativity. They are less good at knowledge. They only know what they were trained on, which can often be of questionable quality. It certainly doesn't include any private information. And graphs are really good at knowledge, context, and enrichment. So, do we know the term retrieval augmented generation? No, maybe. Okay, all right, okay. Well, that's good, right? This is why we're here to learn, right? So, retrieval augmented generation, or RAG, is a process, an approach, an architecture, a design. Put a word in there that you like, that essentially says, how can we give our generative AI applications better context? So, for example, if you're building a chatbot that's in your business, right? But the information you have is proprietary, not public information. It's not going to be in a GenAI model's training data. How do we give it that information? RAG is an approach to do that. And it works like this. So we have a user, we have an application, and we send that to a large language model, and we give additional context. We insert additional context into the prompt, yeah, that allows us to answer that question. And a very typical approach to doing that is to use vector embeddings. Yeah. So to take all your unstructured data, create embeddings from it, use a vector index, and use that as a way of finding contextually relevant information. And it works like this, right? You know, we turn text into numbers, and if we turn text into numbers, we can do comparison against them. She's a small town girl living alone New York, took the midnight train going anywhere, right? Okay. Vectors are great for synonyms, fuzzy, vague queries, open-ended stuff, right? But they are less effective for highly specific information. If you want to find actual facts, vectors will return you more than often more information than you need, which means our context is too big, and our generative AI models do a less good job. We're also pretty terrible at things like logical queries, finding specialist knowledge. All right. So what we can do is we can use knowledge graphs as a way of supplementing the information that we get from our vector embeddings. So if we think about our example here, she's a small town girl living on a lonely world. She took the midnight train going anywhere. We can express that as a vector. We can also express that as a graph. So we can describe the facts about those statements. So we have a node. Oh, this pointer doesn't work on the TV. That's cool. A small town boy is a person who was born and raised in South Detroit, who took a midnight train going to anywhere. That is how we describe data within a graph, through using nodes and relationships. Because context is key, right? Here's a piece of context. I think Neo4j is a great place to work, right? If I took a collection of reviews, I don't know, from Glasshouse or something similar about Neo4j. I genuinely believe this statement, by the way. We could expect a response saying, according to the context provided, Neo4j is a great place to work. It is a great place to work. But context is key. Who made that review? Well, that review was made by a person with a username Emil Efren, who happens to work at Neo4j. Right. According to Emil Efren, the CEO, Neo4j is a great place to work. Right. And it is. So context is key, right? And vectors don't always explain the things that we need, right? And this is where GraphRAG comes in. GraphRAG is was a term coined by Microsoft a couple of years ago out of a research paper they did. And essentially what it said was, if you supplement retrieval augmented generation with facts gained from knowledge graphs, you get better results, right? Fabulous news for Neo4j. Microsoft really sold us a good one that day. Right? So we are going to have a look at an example. I use this quite a lot. So we're going to look at a graph, which is about actors and movies and people that have rated movies. So if you've never seen Neo4j before, the basic structure looks like this. Data is stored as nodes and relationships. Nodes are the big circles. So a node represents a thing, an object, an entity, you know. Tom Hanks, the actor, acted in the movie Toy Story. Actor and movie are labels. That is how we categorize nodes together. There will be many nodes with an actor label or many nodes with a movie label. Relationships have a type. In this case, Tom Hanks acted in the movie Toy Story. We can store data against nodes and relationships, right, as properties. So Tom Hanks named Tom Hank. Well done, me. Date of birth. We can also store data against relationships. Relationships in a graph of real things. So Tom Hanks, the actor, acted in the movie Toy Story, the role of Woody, movie Toy Story released in 1996. So that's the data that we are going to work with. Right. I'm going to swap. So I quite like terminal interfaces, so I thought I'd build one. Right. So what we're looking at here is a very, very simple agent that I wrote in about 45 minutes. And essentially what we have is we're going to ask it a question, and we're going to use a RAG retriever and a GraphRAG retriever. I'm going to send both those queries to the same LLM with the same prompt, and we're going to see the results that we get. And we're going to look at actually how does using graphs to provide context give us more information. So we're going to start with simple, which is, you know, the context, the data that sits behind this agent is that movie graph. So I can ask it questions about movies, right? So let's start with something simple, which is, what is the plot of Jaws? Right, it's relatively simple. And actually what I'm kind of expecting to see here is pretty similar results, right? Okay, so here we go. What we see here is when I asked this question, the agent went off to the graph and basically did a vector search. And it said, okay, well, based on the question you've got, these are the things that I think are the most relevant to that question. And it's basically pulled out every Jaws film. Yeah. And it's the agent has then taken this context to provide me an answer. The plot of Jaws 1975 involves a gigantic blah, 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 right? I have then taken exactly the same question, pumped it through a vector plus graph retriever. So I've taken my vector search and I've then used the graph to supplement that with facts. So the facts that I've added to it is, as well as the plots that I get from the vector, is also things like what genre is it part of? As I can use my graph to find additional information. What the cast is. Yeah. What I've also done is I've said, based on the people that liked Jaws, so the people that rated Jaws, what other movies did they also like? So I've been able to use my graph to expand past that. And by and large, I get a similar response, right? But the question I'm asking is specifically about the plot, right? So let's use this as an opportunity to ask something slightly more complicated. So we're going to say, what genre of movie include vampires? Right. So I'm asking it to say, okay, well, I want you to go and find off vampire films. And now we start to get back subtly different responses. Right. So if I look at this, here is some stuff about movies that include genres. Movies about vampires aren't their genres, right? The important thing to note here is that these genres here are entirely made up by the LLM. It has made them up based on the plot of the movie. It's basically based on the information I've got. I think Vampire Suck is probably a comedy parody film, right? Vampire Suck is, it's certainly a comedy film, but there's an interesting one which is Vampires here. Thinks it's a horror action film. It's actually a Western, right? Yeah, because based on the information it was given, it tried to be as helpful as possible and answer the question I'd given it, but it didn't have sufficient context. But by including my graph to kind of look at the genres that movie was part of, I got better responses. The other thing that I can do, because I have the additional context, is the score that we see here and how it's ordered the vector search is the score based on the vector similarity. The score that we can use from our graph is the rating that users gave that movie, so we can return better quality results. All right. So we're starting to see some differences. We're going to look at a relatively simple one, which is, what movies are about a pig who can talk? What movies are about a pig who can talk? Babe! Right, yeah, perfect. Thank you for the...
knowledge is helpful.
Yeah, thank you for the segue that fits my presentation. Right, so if we look at the response that we get back, we get a pretty similar response back. However, purely based on vector search, it thinks the best answer is a film called Gordy. I've never heard of a film called Gordy. Anybody heard of a film called Gordy? Right. It is about a pig that talks, but actually, given the question we have asked, it is much more likely that what we want is the film Babe, which is well known, yeah, well loved, highly ranked, so on and so forth. All right. So my very last kind of prompt here is, I like The Matrix. What other movies should I watch? Now I'm going to be slightly controversial here. So let's give this a run. I like The Matrix. I think it's a great movie, right? I tell you what's not a great movie is The Matrix Reloaded, The Matrix Revolution, right? These are terrible movies, right? Okay. But interestingly, this pans out in the data that we have, which is actually, if we look at the films that people also highly rated, who rated The Matrix, it's not The Matrix Revolutions and it's not The Matrix Reloaded, right? So it's given me a collection of results that match the information, or actually, you know, the context of what I was trying to get out. All right. So this is why I think we can use graphs to help us add additional context to get better responses. That's what we want. We want responses which are not only well-formed, yeah, which LLMs are great at, but also accurate. This is that little demo I just showed. If you want to have a look, go and have a look there. If you want to know more about Neo4j, almost all of my job is creating educational content. We have a whole Graph Academy platform in completely free. You won't pay for anything, you get certifications, huge amounts of courses and workshops as well. But thank you very much for listening to me. Thank you very much. Thank you.